This line simply indicates that what follows is a multiple-choice question, setting the context for the upcoming choices. This is the core question of the quiz. It asks you to interpret the meaning of the explained variance ratio, which is a key output of principal component analysis, PCA, in Sklearn. I think this statement is correct. The explained variance ratio shows how much of the total variation in your data is explained by each principal component. Adding up the first three tells you the total proportion of variance explained by the top three. This is incorrect. The explained variance ratio is not the same as the eigenvalue. Think of it like this. The eigenvalue shows the amount of variance, while the explained variance ratio shows the percentage of total variance. This is absolutely right. PCA orders components by how much variance they explain. So the first one always explains at least as much as the second, and the second at least as much as the third, and so on. Yes, this is true. If the top three components capture 95% of the data's variance, the other 7 components only account for the remaining 5%. This shows how PCA successfully reduces dimensions. I'm explaining how to interpret the explained variance ratio in principal component analysis, PCA. PCA is a technique to reduce the number of variables in a dataset while retaining most of the important information. We'll focus on understanding what the explained variance ratio tells us. This statement is true. The explained variance ratio for each principal component tells you what percentage of the total data's variability that component explains. Adding the ratios of the first 3 components tells you the total variability they explain together. Think of it like this. If the first 3 components explain 80% of the variance, that means 80% of the spread or variation in your data is captured by just those 3 components. This is also true. PCA orders the principal components to explain the variance in decreasing order. The first principal component always explains the most variance, the second explains the second most, and so on. It's like ranking athletes by their performance scores. The best athlete gets rank 1, the second best rank 2, and so on. I agree, this is true. If the first 3 principal components capture 95% of the total variance, that means the remaining 7 components only account for the other 5%. PCA helps you reduce dimensionality while preserving the most important parts of your data. This makes your model faster and simpler without much information loss. This statement is false. While eigenvalues are related to the explained variance, the explained variance ratio is the proportion or percentage of total variance explained by each component. Eigenvalues represent the amount of variance, but they need to be normalized, divided by the sum of all eigenvalues, to get the explained variance ratio. It's like comparing the size of a pizza slice to the whole pizza. The slice is a part of the whole pizza and not equal to the whole pizza. I'm explaining the meaning of explained variance ratio in principal component analysis, PCA. It's a crucial concept to grasp. Let's dive into this PCA question. I want to test your understanding of how to interpret the results of a PCA analysis, specifically, what the explained variance ratio tells us. This sets the scene of our problem. I'm performing PCA with Sklearn on a dataset with 10 features, reducing to 3 principal components. We want to know how to understand what the explained variance ratio attribute tells us in this context. This statement is true. Adding the explained variance ratios of the first 3 principal components gives you the total proportion of the variance explained by those 3. This is false. The explained variance ratio is the proportion of variance explained, not the eigenvalue itself. Although related, they are not the same thing. Eigenvalues represent the amount of variance, but the explained variance ratio represents the proportion or percentage of the total variance. This is true. PCA orders the principal components based on how much variance they explain. So the first one will always explain the most, then the second, and so on. This statement is true. If the first 3 components explain 95%, then the remaining 7 must explain the remaining 5% of the total information. This is a key aspect of dimensionality reduction using PCA. I'm going to explain what principal component analysis, or PCA, is and how we interpret the explained variance ratio. PCA is a powerful technique used to reduce the dimensionality of your data while retaining as much of the important information as possible. It does this by finding new, uncorrelated variables, principal components, that capture the most variance in your data. The explained variance ratio is key to understanding how well PCA is doing this. The question focuses on understanding the meaning of the explained _variance ratio attribute in Sklearn's PCA. This attribute tells us how much of the total variance in our original data is explained by each of the principal components. Think of variance as the spread or dispersion of your data. The more variance a component explains, the more important that component is. This statement is absolutely true. The explained _variance ratio attribute gives a percentage for each component. Summing the percentages for the top three components gives the total percentage of variance captured by those three components combined. For example, if the first three components have explained variance ratios of 0.4, 0.3, and 0.2, then together they explain 90%. 0.4 plus 0.3 plus 0.2 equals 0.9 or 90% of the variance in the data. This is false. The explained variance ratio is not the eigenvalue itself, but rather the proportion of total variance explained by the corresponding eigenvalue. It's like the percentage contribution of each eigenvalue to the total variance. This is absolutely true. PCA orders the principal components so that the first one captures the largest amount of variance, the second captures the second largest amount, and so on. It's like sorting the components from most to least important. This is true. If the first three principal components explain 95% of the variance, the remaining 7 components collectively only account for the remaining 5% of the total variance. That's the beauty of PCA. We can often drastically reduce the number of variables needed to capture most of the important patterns in our data. This question tests your understanding of PCA's explained _variance ratio attribute. I'll present you with statements about how to interpret this output from Sklearn's PCA function, and you'll determine which ones are true. This statement is correct. The explained _variance ratio attribute gives you the percentage of variance explained by each component. Summing the first three values gives you the total variance explained by those three principal components. Absolutely true. PCA orders components to maximize variance explained. The first principal component always accounts for at least as much variance as the second at least as much as the third, and so on. This statement is also correct. If the top three principal components capture 95% of the data's variance, then the remaining 7 components only represent the other 5%. This is the power of dimensionality reduction with PCA. I'm explaining PCA, a technique to simplify data by reducing the number of features while preserving important information. We use principal components, which are new variables that capture the most important patterns in the data. The explained variance is how much each component describes the original data's spread. I'm presenting a multiple-choice question that checks your understanding of PCA's explained variance ratio. We have a dataset with 10 initial features. After applying PCA, we reduce the features to 3 principal components. The question is all about interpreting the results, specifically the explained _variance ratio attribute in Sklearn. I'm stating that the explained variance ratio for each component is additive. Adding the explained variance ratios of the first 3 components gives the total proportion of variance explained by those 3 components. This is a core concept of PCA that you need to understand. It's like saying if the first 3 components explain 70%, 20% and 10% separately, together they explain 100%. I'm saying that PCA orders components by the amount of variance explained, so the first component always explains at least as much variance as the second at least as much as the third, and so on. This is a key property of PCA's output. I'm saying that if the first 3 principal components capture 95% of the total variance, the remaining 7 original features, dimensions, only account for the remaining 5% of the data's variability. This highlights PCA's power to reduce dimensions without losing much crucial information. I'm clarifying that the backquote explained underscore variance underscore ratio underscore backquote is not the eigenvalue itself. While closely related, it's the proportion or percentage of variance, not the raw variance value, eigenvalue. Think of it like this: the eigenvalue is the total score, while the explained variance ratio is the percentage of that total score in relation to all scores. Got it? I'm pointing out that backquote explained underscore variance underscore ratio underscore backquote is an attribute you can access in Sklearn after fitting a PCA model. It's an array that gives you the proportion of variance in your data explained by each principal component, letting you quantify how much information each component carries. It's a really useful tool. I'll explain what the explained variance ratio is in principal component analysis, PCA. It's a crucial concept to understand how much information each principal component retains from the original dataset. This question tests your understanding of the output of PCA, specifically, the explained variance ratio. I am asking you to interpret the meaning of the Sklearn library's explained underscore variance underscore ratio underscore attribute and its properties. I want to check if you can determine which statements about this attribute are true. This statement is true. The explained variance ratio gives us the percentage of variance explained by each principal component. If I add up the explained variance ratios for the top 3 principal components, I get the total percentage of variance explained by those 3 components combined. This is true. 2. PCA orders the principal components in decreasing order of the amount of variance they explain. Thus, the first principal component always explains at least as much variance as the second, and the second explains at least as much as the third, and so on. This statement is also true. If the top 3 principal components explain 95% of the variance, the remaining 7 principal components collectively explain only the remaining 5%. This shows how PCA helps to reduce the number of dimensions by keeping only the most important parts of the data. This statement is false. The explained variance ratio is not the same as the eigenvalue. Although they are related, the explained variance ratio represents the proportion or percentage of the total variance, while the eigenvalue indicates the amount of variance.